We're about to perform the Benedict's test for the presence of maltose, and we're going to run this test tube containing maltose and Benedict's reagent to serve as the standard to determine if the potato starch that had amylase added broke down to maltose, which is one of the disaccharide subunits. So our standard test tube is labeled M. This test tube contains 2 milliliters of a 1% maltose solution and 4 milliliters of Benedict's reagent. We're going to boil it for 10 minutes and watch for any color change indicating that sugar is present and starch is not. So we're going to watch the test tube color as it's changing immediately before our eyes, starting to turn yellow, is indicating a small amount of disaccharide. As we watch the vial, we see a color change that runs through the entire tube. And it's at the surface where the precipitate is forming with the sugar, showing us the more dramatic change. So we see it changing from the blue color of the copper and the Benedict's reagent through a change of yellow to orange to deep red. It generally can take 10 minutes, but this is moving pretty fast. So we're already starting to see the full effect. This test tube and the observations we make now is what we're going to look to see happening with our test tubes that contained amylose, potato starch, with amylase enzyme, and the control that did not have amylase enzyme. And when we see a color change, that would be an indication of amylose, potato starch, having been broken down from the action of the catalyst we call amylase. Okay, so I'm going to pull this out of the boiling water. So this is about as far as it's going to change. And notice the color, and we're going to remember this color as an indication of the change representing maltose. So now we're going to subject our control vial and our enzyme containing vial at the same time and look to see what color changes occur. Think about what your predictions are for the color change and watch immediately for any change. The B vial indicates the Benedict's test performed on the amylose when enzyme was added, and the BC represents the control in which we had amylose with just Benedict's added. Already seeing the change occur, similar to our control, changing from blue to green to orange. It's starting to look like that bright orange we saw in the standard. And I can see from the surface, and we'll see soon, it's getting deeper, more of a red color. And we'll let it boil until the color stops changing. You can go 10 minutes or less. I'm going to verify that the color change is not different by looking at the top and the sides. And since I didn't see a deepening of color, this is probably as much maltose that's present at this time from the reaction using the enzyme. We had a higher concentration of maltose, we can presume, in the standard based on our current observation. This is typical, this color change, of being less dramatic as the red we saw in the standard. This is typical of what we've seen in the past. So this is successful, and this will conclude our qualitative results for digestion of amylose, a starch carbohydrate using amylase, the enzyme, and checking for indication of the breakdown using Benedict's reagent.